6, 15, 21, and 29. If we feel like we don't need to do any of those, you can let me know. But what I will do is maybe select one problem from here and move on. Okay. So let's look at the number 21 here. So we have a problem concerning limit involving with the square root. So this is section 1.6. 1.6. 21, we're talking about limit. Limit. Square root of 9 plus h minus 3. Plus 3 as h goes to 0. So during my review session, during one of my video lectures, I said that to determine limit, you can try the simple-minded approach, namely substitute the value into the function. However, most of the time, that simple-minded approach does not work because you're going to get a 0 over 0. This is the case here. All right? So therefore, you need to do some algebra to get rid of the 0 at the 0. What you can do, because this is a expression involving square root. So what you can do is to multiply top and bottom by the conjugate, which is the square root of plus 3. Okay, so multiply that to both top and the bottom. And now you apply the formula, the algebra formula. Let me write the formula here. Extremely useful formula. A plus b times a minus b equals to what? A squared minus b squared. This is extremely useful. All right, so we have a plus b and a minus b. That is a squared minus b squared. And that will give you a square. Square and the square root will cancel, so it's just a 9 plus h. See that? The square and the square root cancel. Minus a 3 squared, which is also 9. And then h times that. Nine and 9 cancel, h and h cancel. So you end up with a 1 on the top. And now you can substitute h equals 0 and get the answer. So you're going to get 1 on top, square root of 9 plus 0, which is 9 plus 3, that is 1 over 6. And that's the answer for this one. Question?
I have a question about 1.6 in general.
Yes.
This section, because in the review set problems that Professor Wang gave us and the ones you go over in the videos and stuff, section 1.6 also has stuff like squeeze theorem. Are we expected to be responsible for that?
That would be a more advanced topic. I mean,
I'm just noticing in the problems that, you know, it's fine. We're just going over like limits, like computing and calculating. I just don't want it. I just want to know if I have to focus intensely on, you know, squeeze them. It is in 1.6, but
I think
we haven't done a problem on it. So.
Yeah, given that the review problem does not cover that, I think I'm fairly confident that will not be covered in the final. However, again, I don't want to be liable to that, so don't sue me if it is on the test. Okay. So I just want to make that clear.
So are you going to make an effort then to use primarily the things on the review questions?
Yes. The primarily problem that I believe to be more related to the final exam. That's what I will focus on. All right. Let's move on and look at 2.5. 2.5, we have 23, 29, 41. 5, 3, 29, 41, 3. Let me just do one of them. Let's look at number 41 here. So this is regarding computing derivative. So we have fx equals square root of x plus the square root of x. Okay. So square root of something, this will involve the chain rule. Or you can say generalize the power rule. Let me write down the formula. If I write here, I think it's going to be confusing with the video. Let me write my formula here. So generalize the power rule. Let me write it over here. It says gx to the nth power. All right, and if you take each derivative, what would you get? Well, you're going to just apply as ordinary power rule. And then you have to multiply by g prime at the end. Therefore, n gx to the n minus 1. This part is the usual power rule. And then you multiply by g prime. That is given by the chain rule. Okay. All right, so we're going to apply that. So before you do that, I suggest you rewrite f in the format 1/2 power. That is because square root is the same as 1/2 power. And this allows you to express your function in this kind of standard format. So you can apply the power rule, to generalize the power rule if you want. So x plus square root of x. I'm also going to write this in the form x to the 1/2 power. So I can apply the power rule. And now I can take the derivative of f prime x. Well, apply the power rule to bring the 1/2 to the front. 1/2, and I have whatever inside, that's your dx. Then the power here gets subtracted by 1, therefore minus 1/2. Are you with me? And then you're going to multiply it by g prime x. Okay? Well, g is equal to what's inside. So the derivative of g prime is going to be 1. So you need to put the parentheses here. Plus, bring the 1/2 to the front. X to the minus 1/2 power. And you can say that thing also. All right? I mean, if there's an obvious cancellation, you should cancel it. If it's an obvious simplification, but in this case, I would say this is about good. Okay, any questions? Let's move on and look at 2.6. We have 11 and 17. 2.6, implicit differentiation. 11 and 17. I can just do any one of them. Let's look at a number. For example, number what's that? Did you have a preference? Number 11 or 17? Okay, let's just do number 11. Yeah. So, y times cosine x equals to x squared plus y squared, which is section 2.6. So with all those implicit differentiation, the steps are pretty routine. First, you copy the problem. Okay, everyone can do that. You copy it, and then you just take a dx on both sides. All right, you take a dx on both sides. Keep in your mind that y is really a function of x. All right. So here on the left, obviously you apply the product rule. Okay. So a product says f prime g and f prime in this case is just y prime because y is a function of x. So that's f prime times gx, which is cosine x. That's your f prime times g part. Then plus f, which is y times g prime. In this case, is negative sine x. Okay? And that is equal to the derivative of the right-hand side. What is the right-hand side? Well, x squared gives you 2x. We get a 2x. What is the derivative of y squared? All right. Yeah. If I just say 2y, would that be correct? No. You would need y prime because of the chain rule. Okay? Because y is really a function of x. And now you simply solve for y prime. Well, basically you group the term that has y prime together. Okay, move that to the left and throw in everything else to the right. Okay? And then divide by the coefficient of y prime. Let me actually write on the step. So if you combine in those two terms, you're going to get y prime times cosine x minus 2y. Can you see that? Okay, move those two terms together, take out a common factor, y prime. And then you move the other term to the other side, so we have y times sine x plus 2x. Okay? And then divide both sides by the coefficient of y prime, and you get the final answer. Let me write the final answer here then. Y prime equals to y times sine x on the top plus 2x top, and then cosine x minus 2y on the bottom. That is your final answer. Let's look at 1,000 to the third root. This is number 5. We want to compute the third root of 1,001. We want to compute an approximated value for that. Okay. So to do a problem like this, we always use the formula. Let me remind you the formula, which is f(x) plus h is approximately equal to f(x) plus f prime x times h. Right? Remember that? Sometimes we use slightly different notation. We may use the letter a instead of x, but it's really the same principle. All right. So we define the function f(x). What is f(x) in this case? It should be obvious. It is the third root of x. All right. And it's better to write this in the form x to the 1/3 power, so you can take the derivative. Okay. Now we basically apply the formula here. X, the value of x is equal to 1,000. Okay. Usually you pick a good, nice, friendly number. In this case, it's 1,000. And then you pick h, which will give you the x plus h. So h is obviously equal to 1, yes? So we have to compute everything here. What is f(x)? What is f of 1,000? Well, it's the third root of 1,000, which equals to 10. Okay. What is f prime at 1,000? You take the derivative, which is 1/3 x to the minus 2/3 x equals to 1,000. By the way, this is a good way to write the notation. You put a line here and then put x equal to 1,000, which means you substitute the x equal to 1,000, right? Okay. So this will give you 1/3, 1,000 to the negative 2/3. Well, what is that number equal to? Let's do it on the scratch paper. Because it's negative power, you put it on the bottom. So 1,000 to the 2/3. 2/3 means take the third root and then square. That's 2/3, right? And that will give you 10. 10 squared is 100. So 300, are you with me? 1/300 is what I get. So, yes, 1 over 300. Therefore, your final answer should be 10 plus 1 over 300 times 1. So I'm going to continue with my problem here. Fx plus h. So you can say 1001 to the third root equals to this, which is equal to 10 plus 1 over 300 times 1. You can just say 1 and 1 300. That would be acceptable. Okay. If you prefer to divide it out and say 10.003333, that is also okay. Any questions so far? Let's continue with into the next problem. It might be better if we stop the video every 10 minutes or so.